Hello students, I am Dr. S. M. Bhatti. The objective of this video is to introduce moment, skewness and kurtosis. Beyond the measure of central tendency and dispersion, there are measures that further describe the characteristic of a distribution. And these measures are moment, skewness and kurtosis. Let's start first moment. The earth moment about any number A is denoted by mu r dash and is defined as mu r dash is equal to 1 upon n summation f into x minus a, where this capital N is sum of f. That means capital N is a total frequency. It can be seen that putting r is 0, 1, 2, 3, 4 and so on, we get mu 0 dash as a 1, mu 1 dash as a 1 upon n into summation f into x minus a is equal to 1 upon n summation fx minus capital A, or mu 1 dash is equal to x bar minus a. Mu 2 dash is 1 upon n summation f into x minus a whole square, that became s square, that is mean square deviation. Mu 3 dash is 1 upon n summation f into x minus a whole cube and so on. So in this way we have defined mu r dash. Mu r dash are moment about a. This a is an arbitrary number. You can take a as a assumed mean. Sometimes we can take a as a working mean, but it is not mean. So mu r dash stands for moment about any number a. The earth moment about the mean x bar of a distribution is denoted by mu r and is defined as mu r is equal to 1 upon n summation f into x minus x bar raised to r. So this mu r is nothing but moment about mean x bar. Just now we have seen moment about a and now moment about x bar. Remember, moment about x bar denoted by mu r and moment about any number a denoted by mu r dash. And definition is mu r is equal to 1 upon n summation f into x minus x bar raised to r. Here x bar is arithmetic mean of the distribution. Putting r is 0, 1, 2, 3, 4, etc. We get mu 0 is equal to 1 upon n summation f. But you know that summation f is a total frequency and we have taken it as a capital N. So this result in 1. That means mu 0 is always 1. Then mu 1 is equal to 1 upon n summation f into x minus x bar, and this became 0. Mu 2 is equal to 1 upon n summation f into x minus x bar whole square. This gives the variance of the distribution, that is the square of standard deviation. Mu 3 is equal to 1 upon n summation f into x minus x bar whole cube. This gives third moment of distribution about mean and so on. So mu 0 is the zeroth moment about mean, it is always 1. Mu 1 is the first moment about the mean and it is 0. Mu 2 is the second moment about the mean and it is actually variance of the distribution, that is the square of the standard deviation. And mu 3 stands for the third moment about mean x bar and so on. Let's see now relation between mu r and mu r dash. Mu r dash are moments about capital A, any number capital A, and mu r stand for moments about mean x bar. Let's see now relation between mu r and mu r dash. Here r take value 0, 1, 2, 3, 4 and so on. The value of mu r dash can be calculated with less calculation as compared to mu r by selecting appropriate A. We can see this in the calculation of arithmetic linear standard deviation. By definition, mu r dash is equal to 1 upon n summation f into x minus x bar raised to r, which equals to 1 upon n summation f into x minus a plus a minus x bar raised to r. Here we take d as a x minus a, so that the above equation became 1 upon n summation fd is equal to 1 upon n summation fx minus a upon n summation f, or d bar is equal to x bar minus a, and this became mu 1 dash. Similarly, we can get mu r is equal to 1 upon n summation f into d minus d bar raised to r. Now we expand d minus d bar raised to r. Then we get this mu r is equal to 1 upon n summation f into d raised to r minus c1r d raised to r minus 1 d bar plus c2r d raised to r minus 2 d bar whole square, so on. Last time is minus 1 raised to r d bar raised to r. This is happened by binomial theorem, right? Which can be written as mu r is equal to mu r dash minus c r1 mu 1 dash mu r dash plus c r2 mu r dash whole square, and so on. Last is minus 1 raised to r mu 1 dash whole quantity raised to r, where 1 upon n summation f d raised to r is equal to mu r and d bar is equal to mu 1 dash. We see that mu 0 is 1, mu 1 is 0. By putting r is 2, 3, 4 and so on, we get very important equations. Mu 2 is equal to mu 2 dash minus mu 1 dash whole square. Mu 3 is equal to mu 4 dash minus 3 mu 2 dash into mu 1 dash plus 2 into mu 1 dash whole cube. And lastly, mu 4 is equal to mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash into mu 1 dash whole square minus 3 into mu 1 dash whole quantity raised to 4. If you observe these equations, that is mu 0 is 1, mu 1 is 0 always. But if you observe last three equations, you can see that these three equations represent the value of mu 2, mu 3 and mu 4 in terms of mu 1 dash, mu 2 dash, mu 3 dash and mu 4 dash. In other words, if we know mu 1 dash, mu 2 dash, mu 3 dash and mu 4 dash, then by taking those values in the right hand side of this equation, easily we can get the value of mu 2, mu 3 and mu 4. Like this, we can get the value of mu 0, mu 1, mu 2, mu 3 and mu 4. That means moments about mean x bar can be obtained if moment about any number a are known. Let's see now skewness. It's again one of the important parameters. Skewness signifies departure from the symmetry. We study skewness to have an idea about the shape of the curve which we draw with the given data. If the frequency curve stretches to the right as in the figure, that is the mean is to the right of the mode, then the distribution is a right skew or is said to be negative skewness. If the curve stretches to the left of the mode is to the right of the mean, then the distribution is said to be positive skewness. Here you can see this figure. In this figure, here the skewness is a positive, here the skewness is a negative, right? And here skewness is 0. And if the curve stretches to the left of the mode is to the right of the mean, then distribution is said to have positive skewness. So here I said it is a positive skewness, here is 0 skewness, and here negative skewness. Now the Pearson coefficient of skewness is equal to 3 times mean minus median upon standard deviation. And another is coefficient of skewness, that is beta 1 is equal to mu 3 whole square upon mu 2 whole cube. Let's see now kurtosis. To get the complete idea of distribution in addition to the knowledge of the mean dispersion and skewness, we should have an idea of flatness or peakness of the curve. It is measured by the coefficient beta 2 and is given by the formula beta 2 is equal to mu 4 upon mu 2 whole square. The curve of the figure, which is neither flat nor peaked, is called a normal curve or mesokurtic curve, for which gamma is beta 2 minus 3, gives excess of the kurtosis. For a normal curve, beta 2 is always 3 and the excess is 0. The curve in the figure, which is a flatter than the normal curve, is called platykurtic, and that of the figure which is more peaked is called lipokurtic. For platykurtic curves, beta 2 is less than 3, and for lipokurtic curve, beta 2 is greater than 3. Remember that skewness measures degree of asymmetry or departure from the symmetry, while kurtosis measures degree of peakness of a distribution. And this can be seen in the figure. Let's see that particular figure. Here we can see that beta 2 is less than 3, and so the curve is like a platykurtic, while when beta 2 is exactly 3, then it is a normal curve or it is called as mesokurtic, and when beta 2 has a value more than 3, then it is a lipokurtic. So this is a little flat, this is normal curve, and this is little peaked. Okay, so kurtosis show the peakness of the distribution, while this skewness actually shows asymmetry from the asymmetry, right? For this video, we have taken the help of these two references. In this way, in this video, you are seeing the introduction of moment, skewness, and kurtosis. In next video, we'll solve the examples on moment, skewness, and kurtosis. Thank you very much for watching this video till the end. Thank you very much.